So we continue talking about special segments in a triangle with angle bisector, perpendicular bisector. You might say, we've had that word before. Yes, we have. You remember what an angle bisector does. What does an angle bisector do? All right, it cuts an angle in half. It splits an angle into two equal angles. So drawing the angle bisector is just like jink, and then you label the two equal angles. We're not labeling anything else. We're not labeling like an altitude or a median because we don't know. We're just cutting the angle in half, cutting the angle in half. It's one of the easier ones to draw when we want to draw all three of them. So we're just eyeballing cutting the angle in half. If you have three colors, it's kind of nice to do them in all three colors. There's that angle in half, and here's this angle in half. And notice I've marked each one a little bit differently. You've probably seen it coming that they're all going to meet in a point, and the angle bisectors are going to meet in the in-center. So again, we notice a vowel with a vowel. Angle bisector, in-center. Going back to what we've learned previously or what we've seen before is equal distance, right? If it looks equal, it is equal. Any point on the angle bisector is going to be equal distant from the endpoints of the segment. So that's going to be 22. Or here, x minus 8 equals 35, making x equal to 43. And if I plug that 43 back in, 43 minus 8 again is 35, right? Equal distance, equal distance. 3x plus 2 equals 20. If I subtract 2 from both sides and divide both sides by 3, I get x equals 6. If I plug that back in, 6 times 3 is 18, plus 2 is 20. So some simple questions about being equal distance. Next one is a segment, right, or line that makes a right angle at the midpoint. Do you know what that's called? Perpendicular bisector. Perpendicular bisector. Makes a right angle at the midpoint. So here I said draw and label the perpendicular of side xy. So I think I forgot my xy's here. So I'm going to add the xy, side xy. You do a perpendicular bisector of a side. You find the middle, and then you make a 90-degree angle. It may or may not go through the corner. It's a little bit of a sloppier picture. Find the middle, and then kind of go straight up and down. So a perpendicular bisector. This one is a nice triangle. It kind of does go through, well, yes and no, like they kind of cut it off. Like this is really the perpendicular bisector going straight up, but they just did the piece in the middle. So you could see how they all three meet. And then our last crazy word is circumcenter, where the perpendicular bisectors meet. And again, we have consonant and consonant. Again, we see this word equidistant. It's the same. 3 matches 3, therefore 7 matches 7. Here, the 12x is going to equal the 96, so x equals, what, 8. And then here, the 6x plus 1 equals 4. So x equals 1/2. It is a lot of vocab, right? So we'll work on that, but perpendicular bisectors, and those are equidistant, and then angle bisectors, and those are equidistant.